Hello everyone, welcome back. So today's lead code daily problem is special positions in a binary matrix. Once again, a 2D array problem. So let's read about the statement. So given an m cross n binary matrix, return the number of special positions in matrix. So we have given a binary matrix. So what is binary matrix? So binary matrix consists of only ones and zeros. That is binary numbers. You can see this example. And we need to return the special positions in matrix. So now what are these special positions? A position I comma j is called special if mat ij equals 1 and all other elements in row I and column j are 0. So, so special position will be that position where the current element is 1 and it is the only one in that entire row and in the entire column. So here in this example, you can see this one is only one in this entire row and in this entire column. That's why it has qualified as the special position. So the statement is very lucid. We have understood it. Now let's move towards the solution. So to solve this problem, we can have two approaches. The first one is very basic, that is brute force. So I will orally explain the brute force approach. Uh, so in the brute force approach, we'll be iterating over this array, this 2D array. And for every position where we will find one, we will be checking the entire row and that entire column that there should be no other one. Then only we will count that position as the special position. So we need to run, maybe we need to create two separate functions, one function to check the row, that entire row where we have find the one, and one function that will check the entire column that there should be no other one. So that way the time complexity will increase uh, to other level that it already this the time complexity of iterating over a 2D array is big O of m cross n. So it will be more because for every particular index we will be moving, we will be iterating the entire row and the entire column. So this one is about the brute force approach. Now let's talk about the little efficient approach. So in this approach, I'll be using some extra space, and that extra space is for storing the number of ones in the particular row and the number of columns. And in the second array, I'll be storing the number of ones in the particular column. So in the first array, I'll be storing number of ones in like row 1 at the 0th index. I will call this as the row 0. And in the row 1, I will be storing at first index the number of ones and so on. Similarly, in the column ones array, I'll be storing number of ones in that particular column. Like suppose in this column we have two ones, then at the 0th index, I'll be storing 2. And similarly, for the first index, I will store 0. And for the second index, I will store 1. And after that, I will iterate over this 2D array. And I will check whenever I will get the 1 at any index, I will check that my row 1's array and column 1's array for the particular index, it should be only 1. Because in this entire row, there should be only single one, and in this entire column there should be only single one. But here we can see there are two ones, so the count for that index will be 2, and we will be returning false from there, and we will not count this one as the special position. Okay, let's dive inside the code directly, and I will explain you everything by the small dry run of this problem, this example one, after finishing the code. Then it will make more sense. So let's define first one variable like int m, or I can say number of rows. Let's take not number of rows, rows will work. So the int rows will be mat.length. So we will have rows as mat.length. And then we will have one more variable, that is calls. So number of columns will be mat of 0, because I will take any one row and I will take the length of that row. So I'm taking the 0th row. Okay, fine. Then I will have a counter that will return the my result, final result. So I will initiate it with 0. Then I will define two arrays. So two arrays. One is for row ones. It will take the count of rows. So new int, and its size will be equal to rows, number of rows. Fine. And there will be one more array. It will be storing the column ones, count of column ones. Yes, and this is new int, and its size will be equal to calls. Fine. So this is about the definition. Now let's populate. Let's populate this. Uh, these arrays. Populating count arrays. Count arrays uh, for row and column. So for that, we need to run a for loop, and it will be like nested for loop, and I equals 0 and I less than rows and I plus plus. Okay, and we need to take one more nested loop, int j equals, it will start from 0 and it will go up till columns and j plus plus. Fine. Now I will check if the current position, if matrix of I and matrix of I comma j is equals 1. If it is equal to 1, then I need to increment the counter for this particular row. So row ones of I will be plus plus, and column ones of j will be plus plus. So particular, suppose if on the 0th position, on 0 comma 0, I have got 1, then on the row 0, on row 1's 0, I will be putting 1, and on row on column 1's 0, I will be putting 1. So this is how I will manage the number of the count of number of ones in the particular row and the particular column. Fine. So I'm done with the code in this thing in populating these two arrays. Now I need to counting special positions. So to count special positions, we need to iterate over this array, and we need to check that whenever we're getting one, we will be checking one more thing, that in this particular row, do we have only single one, or in this particular column, do we have only this single one? Then only we will be counting. Then only that will be uh, position will be considered as the special position. So I will be iterating. I will be iterating over this array by running the nested for loop, and I will be checking this matrix of I j equals 1. Okay. Along with this, I need to check these two arrays, that row ones and column ones. That row ones of I should also be 1. Fine. Row ones of I should also be 1. And column ones of j should also be 1, because that is the beauty of the special position. Fine. Should also be 1. Then only we'll be counting the, we will be incrementing the count plus plus. Okay, fine. And finally, we will return our count as the answer. Return count. Okay, fine. So let's try to run this code. I think there is no compilation error. Okay, it has got accepted, and let's try to submit it. So we can see the time complexity for this code is big O of m cross n, because we are at one time we are just iterating over it. Okay, and space complexity is little bit more because we are using this extra space. So space complexity will be big O of m plus n, because we are using m plus n extra space to arrays, right? Okay, so this is about the code. Now let's move towards the dry run as I promised for this example. So for that, I have drawn one image. Okay, so from the start, uh, let's begin from the start. Okay, and let's increase the size of this thing. Fine. Or I will use this thing. Fine. Perfect. And let's take this as some dark blue color. Okay. So what we were doing in the code, that first we were iterating over this 2D array, and and sorry, and we were storing the count of ones in the particular row and in the particular column. So let's start with this index. It is 0, comma 0. And on this index, we have found 1. So our that thing is our condition is qualified, that this condition, let me show you, that this condition, if matrix of ij will be 1. So we have found 1. Now what we will do? We will increment the array that for this I by 1, and we will increment this column one's array by 1. Okay. So I is 0, j is also 0, I is also 0, j is also 0. So at this rows array, we will increment it as 1. I'll put 1 here. Okay. Should I increase the size? Okay, let's take 24. Let's make it 1. Fine. And I will increment this array also by 1. Let's make it 1. Okay. Now let's move to the next position. This is 0, so we are not bothered about it. And this one is also 0, so we will leave this also. Now we will come to the next row. Here, this is 0, so we'll leave this also. This is also 0, not an issue. This is 1. So this is 1, then this index is 1, comma 2. So 1, comma 2. So in the second index of row, we will be incrementing. In the first index, in the rows, we will be incrementing 1. So here we will be putting 1. And in the second index of column array, we will be putting 1. So second index is this, we will be putting 1. Fine. And now we will move towards the last row. So this one is 1. So here on the first index, of rows column, sorry, in this row, this is the, on the second index of the rows, we have only, we will increment the second index. So it is initially nothing, so it will become 1. From the rows perspective, it will become 1. And from the columns perspective, the zeroth index will be uh, incremented by one, because already here is one, so it will get incremented. So I need to remove it from here, this one, and I will increment it by one. Uh, okay, let's not remove it. Let's make it two by just putting plus one here. So it will get incremented by one, and it will become equal to uh, okay, let's say two. Fine. And let's move it here. Okay, so this index has become two. Fine. Now we are done iterating. We are done populating these arrays. So by default, here will be 0, because this is an int array. So by default, value will be 0. Now we will iterate over this array and count the number of special positions. So this for this 0, 0 position, we will check that whether the zeroth index of rows column is 1. Okay, this is 1. Fine. Now we will check whether the zeroth index of columns array is 1. We will check zeroth index of columns array. It is not 1, it is 2. So it will return the false. So now this is not qualified as a special position. Now we will move further. It is 0. It's just failing the primary criteria. It is also 0. We'll move forward. It is also 0. Move forward. It is also 0. Move forward. It is 1. So it is 1. So we will check that whether the first index of rows array is 1. Okay, first index, it is 1. Okay, fine. Now let's check whether the first index of whether the second index of columns array is 1. So second index of the columns array is 1. Okay, fine, we have got this as a special position. So we will ever increment our count. So initially our count was 0. now it will become now it will become uh, 1. Okay, fine. We will move forward. We will get here we will reach on this index. So this is 1. Okay, fine. Now let's check the zeroth index of column, whether it is 1. Zeroth index of row, whether it is 1. Zeroth index of row, it is 1. Okay, fine. Now let's check whether the second index, sorry, whether the second, sorry, we need to check the second index for rows. So second index for row, because this is a row. So second index for row is 1. Okay, fine. Now we will check whether the zeroth index for column. Zeroth index for column is 1. So zeroth index for column is 2. No, it is not qualifying as a special position. So we will move forward, and then we have only zeros. So this is how our output will be 1. Count will be 1. You can see this answer is also here 1. So this is about the dry run of this problem. It was uh, not that difficult problem, but it was uh, comparatively easy problem. That's why LeetCode has put this in the easy category. So this is it about this video, and I will see you in the next one. If you like this video, then please subscribe to the channel and share with your friends, and keep learning, keep growing. And I have uploaded one more. I've started one more playlist also, that is for the top 150 interview questions on LeetCode. So I will try to upload one video in that series daily. And if I'll fail to upload daily, then I will make sure that I'll upload next day 2 videos, or we can skip some day, because if the problem is too difficult to understand for me, then I need to make a lot of preparations to make you guys understand. So this is about this video, and okay, bye bye, all the best, take care, stay healthy, bye.